Everyone, this is going to cover the last lesson for solving systems of equations. So far we've seen solving systems by graphing, by using a table, by using substitution, and today we are going to learn how to use elimination. Okay, so with elimination you get rid of one of the variables by adding or subtracting equations. You may have to multiply one or both of the equations by a number to create variable terms that can be eliminated. So these are the steps. So step number one, get both equations in standard form. So this is what's different about this method, okay? If it's not written like this already. Step two, stack equations on top of each other so that like variables and constants line up. 3, check to see if one of the variable terms could be eliminated by adding the two equations. If not, multiply one or both of the equations by a number to create a variable term that can be eliminated. 4, add the equations or add the two equations and solve for the non-eliminated variable. Plug your solution into either of the two original equations and solve for the other variable. Okay, so let me walk you through the first example. Okay, the first example, it's going to be a simple one to do. So the first thing you have to look at is they have to be in standard form. So ax plus by equals c. So this is a constant. And as you can see, the value of a in this case is 2. The value of b is -1. And this is already in standard form. Then look at the second one. The second one is also already in standard form. Okay, so ax plus by equals c. So once you see that this is set up in standard form, both of them, then you can right away see that if we were to add these two functions, okay, and again, they're stacked on top of each other, the y's line up, the x's line up, and the constants line up. So all I'm going to do is combine the two functions in this case. So then I add 2x plus 4x, that gives me 6x. Negative y plus y, the y's cancel out, so that means I'm done with y, so I just have 0 plus 12, that's going to be 12. So this is why this is called elimination, because we have eliminated y, and now we only have to work with x. Okay, so next step is I'm going to divide by 6, and then we find that x equals 2. Next, I'm going to use this value of x on the first equation. Okay, so then this is going to be 2, and instead of x, we just found that x is 2, and then subtract y, and that equals 0. So then 2 times 2 is going to be 4. 4 minus y equals 0. And then we subtract this 4 from both sides of the equation, so we have negative y equals -4. And then we divide by -1, so we find that y equals 4. So the solution to this system by using elimination is 2, the value of x is 2, the value of y is 4. And this point is the solution to the system of equations. Okay, so let's go on to the next example. Okay, example number 2. Again, check that this is in standard form. So I see ax, by, c, ax, by, and c. All right, but there's a difference here. On this example, watch, I cannot eliminate the x's because this is a 5, that's a 4. This is a -3, that's a -6, so nothing eliminates here. So I'm going to have to multiply one of them. Notice that this one is a 6, right? And 3 is a factor of 6 because 3 goes into 6 2 times. But this one is negative and this one is also negative. So if I combine these two, they're not going to cancel out. If I combine the x's, they're not going to cancel out. So I'm going to manipulate the first equation. Okay, I need to multiply. I need a 6, but that 6 has to be positive. So I need to multiply this equation by a -2. So then when I do that, this gives me, so I'm going to distribute that -2 to the 5x. So it's -10x and -2 times -3y plus 6y and -2 times 18. That equals -36. And then this one, I'm just going to bring it over. So this is 4x minus 6y equals 0. Okay, so as you can see, the y's, 6y minus 6y, they're going to cancel out. But -10x plus 4x, because these are positive 4x's, so this is -6x's. and that equals negative 36 minus 0. It's going to be negative 36. Now we just divide by negative 6, and this helps us find the value of x. So then we have that x equals negative 36 divided by 6 is going to be 6. Okay, and we know the value of x now, so I'm going to go back to one of these equations, and I'm going to do it on this one here, the second equation. So this is going to be 4, okay, and instead of x, it's going to be a 6 minus 6y equals 0. So 4 times 6 is going to be 24, minus 6y equals 0 again. So then subtract this 24. So then we have negative 6y equals negative 24. Last step is I'm going to divide by negative 6. So then y equals, what is this? So this will be 4, right? So now my solution to this system is going to be 6 and 4. And in this case, we are using elimination. Okay, now if you plug in, or if you go back and substitute 6 into the first equation, you will also find that y is equal to 4. So you can choose any of the two equations. Okay, don't just think that it's only the second one. So let's go ahead and do one more example. So this example number 3, let's see, I have 3x minus 15y and 5x plus 2y. See here, I'm going to have to manipulate both, right? Because I can't multiply, let's say, the second one, because 2 is not a 15, it's not a factor of 15, and 5 is not a factor of 3. So I'm going to have to multiply both. Okay, so the next thing is you have to decide which of the two equations you want to eliminate. Okay, so let's see. So in this case, we are going to manipulate it, but also notice that the first equation is not in standard form. So I'm going to rewrite this equation in the following way. So I'm going to bring the 7y's to this side, and I'm going to bring the 15 to this side. So I'm going to add 15 here, okay, and also here. So that I have this in ax plus by equals c. And then I'm going to add the 7y to this side and also this side. And I hope you're seeing what I'm doing here. So then this becomes, I have the 3x's, okay, they're here, but now I added 7y to the left hand side, and then I added 15. This 15 is now on this side of the equation, okay, so now this is in standard form. The second one, I don't have to do anything to it because it's already in standard form, so I'm just going to copy it the way it is. So 5x plus 2y equals negative 4. All right. So then the question is, well, I'm going to eliminate x. Even though you can eliminate y, I'm going to eliminate the x's in this case. So what number do I need to multiply this 3 and this 5x's to get the x's to cancel out? Well, if I multiply these two, 3 times 5 is 15. So I need to have a 15 here. So it's got to be a negative 5. Okay? And this one has to be... we can do a positive 3 here. So then this will be negative 15x, and this will be positive 15x. So let's see what happens here. So negative, for the sake of space, I'm going to bring this over here, okay, because I don't have a lot of space to work with. But negative 5 times 3x is going to be negative 15x. Negative 5 times positive 7y, that's negative 35y. And negative 5 times positive 15, that's equal to negative 75. And then this one, 3 times 5x, that's going to be positive 15x, which is what we wanted. And 3 times 2y, so that's going to be plus, let's see, so that's going to be 6y, equals 3 times negative 4, that's negative 12. Okay, and now let's eliminate. So the x's eliminate, and then we have negative 35y plus 6y. That's going to be negative 29y. And that equals negative 75 minus 12. That's equal to negative 87. Okay? And when we divide by 29 on both sides, negative 29, we find that y equals in this case is 3. Since we know y is equal to 3, then I'm going to come back to this one here. So I'm going to say, I'm going to take this equation, 5 times x plus 2 times 3 equals negative 4. So this is 5x plus 6 equals negative 4. And then subtract the 6 from this side and also this side. So then 5x equals negative 10. And then last, divide by 5, so x equals negative 2. So the solution to this system is negative 2 for x and 3 for y. And I'm going to stop here and I'll let you guys do the last problem, okay? And I'll talk to you soon. Thank you for watching. Bye-bye.